Today's topic is sequences, where we'll discuss two of the many sequences in the math world. There's tons of them. In Algebra 1, we talk about two of them. We'll talk about arithmetic, and that's how it's pronounced, arithmetic, and then geometric. An arithmetic sequence is when you add the same value repeatedly. Now, adding, remember, could be a positive or a negative. So I'm going to put that here so we remember that. So just because it's going down, you're still adding a negative number. So let me give you an example. The first example we'll look at, it will be a simple one, 10, 16, 22, etc. Most of you realize what's happening here. If you don't, though, it's very simple to determine. If you don't know if it's arithmetic or geometric, well, the first thing you do is you take the last term, 22, and you subtract from it the term right before it. 22 minus 16 is 6. And you can do this on the calculator. You don't have to do it by hand. And then you do the same test with the next number, 16, and you subtract the number before that. If you get the same thing every time you subtract, then that is the difference. That's the number that's being added over and over and over. In this case, that's a positive 6. So you can tell that the next term is going to be plus 6, so 28. The next term plus 6, 34, etc. Now, there's a formula that we can use to determine future terms. Obviously, we can just keep adding 6 over and over again. That's going to take forever. The formula is very simple, and we can derive that, and we're going to derive that in another day. But we start with our first term. We're going to call that A. Then we're going to add the same value over and over again. We're going to call that a common difference. So we're going to say A plus D. D is a common difference. And then when we add that, instead of adding it over and over again, remember adding is the same thing as, or adding something repeatedly is the same thing as multiplying. So if we add 6 plus 6 plus 6 plus 6, that's the same as 6 times 4. So we'll write times x, but we don't want to do x. We'll see this later. We're going to put x minus 1. So the formula that we use to find any term of an arithmetic sequence is a, first term, plus d, common difference, times x minus 1. Now, a quick example, if this were going down like 10, 7, 4, if we do our little trick, we subtract, 4 minus 7 is negative 3, 7 minus 10 is negative 3. In this case, this will be D. The way in our original equation, our original sequence, 6 was D. So it's always the first term plus the common difference times x minus 1. So a couple things to always remember. First of all, our arithmetic ones are the ones that add or subtract. We test it by subtracting backwards. So make sure you write that in here. That's very important. We subtract backwards. So you take the last term, subtract the term before it, and so forth. If we get a common difference, it's the same thing each time, then that is D, the common difference. Next, we'll take a look at our second term, or second type of sequence, which is a geometric sequence. And a geometric sequence is when you multiply by the same value repeatedly. Now, you may be thinking to yourself, if I multiply by something over and over again, it's going to keep getting bigger and bigger. Not necessarily. You can multiply by a number and get smaller. When you multiply by a fraction or a number less than 1, your value actually goes down. When you multiply 7 by 1/2, you don't get bigger than 7, you get 3.5 or smaller. Which leads us to our first example that you see here, 1, 5, 25, and 125. Now, you should be able to see by looking at it that that's not going to be an arithmetic sequence. 125 minus 25 is 100, and 25 minus 5 is 20. So it's definitely not going up by adding the same thing. So just like before, if we can tell what, it's not arithmetic, then we can try and see if it's geometric. And there is a test. Again, we can divide backwards. So what we can do is take our calculator and do 125 divided by 25, which gives us 5. Now, if we do the next one back, 25 divided by 5, if it is geometric, we should get the same thing, and 25 divided by 5 is 5. If we do it one more time, just to prove it, 5 divided by 1 is 5. That means we get 5 each time. That is called, and not a geometric, or not a common difference, but that is called a common ratio. Ratio being something you multiply. Now, I'll show you an example in a minute, but that number doesn't have to be a whole number. It doesn't have to be a number greater than 1. It can be a smaller number, like a fraction or a decimal below. Now, the key to remember this, I've said multiply up here. When we go to write our formula, it's very similar. We start off with our first term, g. We'll call it g. That's our first term of geometric sequence. But we're not adding something or subtracting something over and over. We're multiplying something. And that thing we're multiplying is the common ratio. R is the common ratio. So we're going to multiply that over and over again. Now, just like before, if we do something repeatedly, that actually advances a level. So if we multiply over and over and over again, that actually is an exponent. So what we'll do here is just have g times r, but instead of x times x, we'll have to the power of x minus 1. And that'll give us future, or the entire sequence, but also future terms in that sequence. So for this particular example, our first term was 1. We are multiplying by 5 every single time to the x minus 1. And if you put that in the calculator, you'll see that the next term is going to be, it'll follow 5, 25, 125, and then 625, and so forth. Now, I mentioned earlier that a sequence like this doesn't always have to go up. Sometimes it goes down. So we'll look at a different number real quick. We'll look at 20, 10, 5. One that's obviously not going up, it's going down. If we were to do our trick and do 5 divided by 10, we would get 1/2, or 0.5. If we continue that and did 10 divided by 20, we would also get 0.5. So our ratio in this case is 0.5, which means when we go to write our formula, we start at 20, we multiply by 0.5. Now notice I'm not putting a divide. I haven't even said the word divide except to tell you don't use the word divide. I'm not using a division symbol. I'm dividing here to go 5 divided by 10 to get 0.5. That's my ratio. So it's going to be something like that. If you put that in, you'll see the rest of it. 20, 10, 5, 2.5, 1.25, and so forth. So again, geometric is one where we're multiplying and it can go either up or it can go down. We test it by dividing backwards. And then our ratio is either a whole number or a decimal. Don't need to change the fraction, but let's put in here, never divide. Because if you write that down and you type an equation that has division, I will probably count it wrong. We don't want that to happen. All right, let's go ahead and practice now. In just a moment, go ahead and pause the video, try these 6, make sure you're doing okay with it, use the calculator and whatnot. I've set it up where the first 3 are going to be arithmetic and the bottom 3 will be geometric. That way it kind of gives you a hint. If you want to test the others just to prove that it doesn't work, go ahead. But make sure you do the test. Don't go by your own wits, but do the test to make sure you can see it and then plug in the calculator. And then for the last term, we'll come back to that. You can go ahead and pause and check your answers now. But you can see the sequences continue on. Be sure to double check your equations. We can now use the equations, using the calculator, use the equations to find the term of each one. For example, to find the 37th term, I'm just going to go to the calculator. I'm going to type in 3 plus 4. If the 37th term is x, that's going to be 37 minus 1. And yes, if you want to put 36, that's fine. For the next one, if you want to put 24 minus 11 times 29 minus 1. And then for the last term there, I would put in negative 213 plus 42 times 50 minus 1. Go ahead and pause that and work those out. And for the first one, you should get the 37th term is 147. For the second one, the 29th term is negative 284. And for the third one, the 50th term is 1,845. Now do the same thing and check the last 3. The equations we should use to get the 8th term would be 2 times 3 to the 8 minus 1, or 7th. For the next one, we'll try negative 3 times 2 to the 7 minus 1, or 6. And for the last one, we would try 1,000 times 0.75 to the 6 minus 1. And now to check them, the first geometric sequence, 2 times 3 to the 8 minus 1, would give us 42. The second one, negative 3 times 2 to the 7 minus 1, would give us negative 192. And the third one, the sixth term, well, we've already got it here. But if you calculate it out, it's going to give you 237.3046875. Now, we don't need that much number, but we would have it if we needed it.